So I just wanted to post a video that just had another example about graphing trigonometric functions. So if I look at this, this is y equals 3 times sine of 2t. Think about the inputs. The inputs are t. Those are angles. The outputs are y. Those are, like on the unit circle, they'd be the height. So I have some multipliers in here. If it was straight sine, I know that sine starts at 0, goes up to 1, down to 0, down to -1, back up to 0, and repeats itself. And I know that the period is 2 pi. Like, after 2 pi, it starts repeating itself. But notice what's happening to the inputs here, the inputs t. They're being multiplied by 2 before sine is applied to them, before sine gets to them. So what's happening is, like, sine is getting this information twice as fast as it would get. What I mean is, like, if I plug in pi for t, I multiply it by 2, it's actually now 2 pi, and I go sine of 2 pi. So what that does is this makes everything happen twice as fast. So if my standard period is 2 pi, my period for this specific function will be 2 pi divided by this rate, how fast it's happening, divided by 2. Like, everything happens twice as fast. So it only takes pi for this to start repeating itself. So let me start thinking about the graph of that. So I know that 1, 2, 3, 4. I basically have these 4 important parts that I'm going to worry about. I know it's going to repeat itself at pi, so I'll make that my extreme. If I cut that in half, halfway to pi would be pi over 2. Cut that in half, pi over 4. 1 pi over 4, 2 pi over 4. This would be 3 pi over 4 then. So there's my kind of my inputs for my main part. Now sine itself, like I said before, starts at 0, then would output 1, then would output 0, -1, 0. But notice what's happening with this. Sine, after you do sine, these inputs 0, 1, 0, -1, 0, actually get multiplied by 3. It gets stretched this way, 3 times bigger. So it can still start at 0, but it doesn't just go up to 1, it goes all the way up to 3. And then it goes down to 0. Then it goes down to -3. Then it goes back up to 0. And it keeps going like that. Notice if this was 5, it would have gone up to 5. If this was 1/2, it would only gone into 1/2. Let me do one more example. So let's say that y equals, I'll do 5, but in this case I'll do sine of 1/2 of t. So same sort of thinking as before. My usual period for sine is 2 pi. That's how long it takes for it to start repeating itself. This 1/2 is making it go half as fast. So actually, like if I plug in 2 pi for t, I'm only going sine of half of that, sine of pi. Like I haven't done a full rotation yet. So the period for this, it's half as fast as it was going, so it should take twice as long. So 4 pi is actually the period for this. So let me start to get a sketch of this on here. And in this case, I'm going to go, I'll just go 4. So 4 pi is when it starts to repeat itself. That means this would be 2 pi. So this is pi. So this is 3 pi. So it's going to, in sine, when I get 0 and pi into here, it would be a 1, just sine itself. So sine itself, like I know, it starts at 0, then it goes up to 1, down to 0, down to -1, out to 0. But it's multiplied by 5. So instead of these, it's stretched by this by a multiple of 5. So it's actually going to go 0, 5, 0, -5, 0. So 1, 2, 3, 4, 5. 5. Starts at 0, gets up to 5, back down to 0, down to 5, back to 0. So there we go. In general, if I had y equals a sine, and it could be cosine, of bt, this is my period. This is how fast things are happening, right? This is about the period. The period is always going to be 2 pi over b. This a is the amplitude. It's the height from the middle of the wave to the top. Or like one person said in class, half of the total distance. So this multiplier stretches it this way or shrinks it, depending on, like if it's less than 1. This multiplier compresses it or spreads it out in the x direction.